All right, lesson 3.3, direct variation. And this is the equation in y equals mx form. So this is what direct variation looks like in this form right here. And I'm going to work through just a few problems so that you can do your homework. Okay, so here we have the advertising. The number of vehicles a dealership sells varies directly with the money spent on advertising. How many vehicles does the dealership sell for each $1,000 spent on advertising? So what we were trying to find out is how many vehicles does this dealership sell for each $1,000? And it says the number of vehicles varies directly with, so number of vehicles right here, number of vehicles varies directly with the money spent. Okay, so here, if we're looking at the graph, we have the money spent is down on the X, and the number of vehicles sold is on the Y axis. So this is the number of vehicles is our Y, and the money spent is our X. So we're going to use this form right here. So we want to know how many vehicles does the dealership sell for every $1,000. So if we're looking here, we got to find points on this graph, and I'm looking closely here. It looks like we have a point on the graph right there, and I think we have a point on the graph right here. So this point here looks like it's 5 and 40, and actually it's 5,000 because these are counted in thousands, and this one up here is 10. Let's see, 10 and 80. Okay, so I have those right there. So how do I find out per thousand? Well, in direct variation, since I have this y equals mx, I do have my x value and my y value right there. So I'm just going to plug that right in. So I'm going to say 40 equals m times my x value is 5. And then to solve for m, I'm going to, since m is being multiplied by 5, I'm going to divide by 5 on both sides, getting my m by itself, and I get 8 right there. So how many vehicles do they sell per thousand? It sells 8 vehicles per $1,000 right there. Okay, here I'm going to do number 3. Number 3, solar energy. The power absorbed by a solar panel varies directly. So the power absorbed, right here, power absorbed varies directly with its area. If an 8 square meter panel absorbs 8,196 watts of power, how much power does a 12 square meter solar panel absorb? So when we say varies directly, again, the first one will be our y, and the second one will be our x right here. So our x is area, and the power absorbed by the solar panel is our y. So the ones in power. So what do we have? We have 8 square meter panel right here, and we have 8,160 watts of power. So guess what? We just gotta put it into our varies directly form, the y equals m times x. So which number is our y? Which one is our x? So power absorbed, area. Well, if you don't know what units are, but this says power absorbed, and this one says 8,160 watts of power. So this must be our y value right there. And this, if you forgot, area is measured in squared units. So this is a square meter. So this is our x. So what we're going to do is go ahead and plug these values into our equation, our direct variation equation. So I'm going to get 8,160 equals m times x, which is 8. And we're going to figure out what m equals by dividing 8 into both side so we can get our m. And how many does it go? It goes in 1000, 0, 2, 0. This is our m. So this is not our answer. What we're going to do is use this to help us find how much power does a 12 square meter solar panel absorb. So this was step 1. Now step 2 is we're going to rewrite our equation, but now that we know what our m is, we're going to have to use this 12 square meters. Remember, 12 square meters is our x. So now we're going to use this new x to find the answer to how much power it's going to be. So I'm going to go y equals 1020 times 12. And what does that equal? So I multiplied and got 12,240 watts of power. So this is our answer because the question was how much power. There it is. Okay, in this section, we want to determine whether each linear function is direct variation. So we want to know, does it fit the y equals mx form? If so, then we can state the constant of variation. And the constant of variation is this m right there. So we just got to figure out what m equals. So this first one, we have our x and our y right here, 2 and 5. So we can go ahead, 2 and 10. And we just plug it right into this direct variation form. So 10 is y, m, and then x is 2. So when I plug that in, I can solve for m by dividing by 2 on both sides, and I get m equals 5. So does that equal the same time? Does this work for each and every one of these? Well, let's see. 4 into, so we did 2 divided into 10 is 5. 4 divided into 20 is 5. 6 divided into 30 is 5. 8 divided into 40 is also 5. So this is, yes, this is direct variation. Direct variation. So our whole answer is right here. It is direct variation, and our constant of variation is 5. Let's move over to number 6. Try the same thing. So here we want to do our division again. So we have 95, and we have our m, and we have our 5. And if I divide both sides by 5, I end up with, how many times does it go in there? 19 times. And so let's see. 10 goes into 190, 19 times. And then let me check these on the side. So let's see. 285 divided by 15 is 19. 380 divided by 20 is 19. So there we go. This is also direct variation because it worked for all the points. So there again is our constant variation is 19 right there. Okay, so this part, it says if y varies directly with x, write an equation for the direct variation. So again, direct variation looks like this. M equals y, y equals m times x. Then we want to find the value, each value. So here, so what we're going to do, there's going to be 2 steps. Step 1 is we're going to look for the m, or calculate the m. And then once we find our m, we're going to find the missing letter. So here, number 9, we have if y equals -5 when x equals 2, we're going to use that in our direct variation. So we're saying -5 equals m times 2. We want to find y when x is 8. So step 1, find m. So to find m, we're going to divide by 2 on both sides, and we end up with a fraction. -5 over 2 equals m. So step 2, we're going to take that m that we found and write it as an equation. So y equals -5 over 2 times x. Now we want to find what y would equal when x is equal to 8. So how do we do that? We just plug in 8 for x and solve. Right there. So we're going to plug in 8. So now we're going to go -5 over 2 times 8. And we can put the 8 over 1, which makes this a -40 over 2. And that simplifies to be negative 20. So y would be negative 20 when x is 8 from this direct variation. Okay, last one here. We have another one with a two-step. So the first step is we're going to find our m, because we have if y equals negative 7 when x is negative 21. So this is going to be times 21. And so again, we want to find m by dividing by negative 21. And again, we end up with a fraction, but this time we have 7 over 21, which can simplify to 1/3, because if I divide both by 7, I get a fraction of 1/3. Step 2 is now I want to know what the value of x is when y is 9. So I'm going to go ahead and use my new equation that I have with the m. Y equals 1/3 x. And now to find what x is going to be when y is 9, I'm going to plug in 9 for y equals 1/3 times x and solve this equation. So how do I solve this equation? Well, if I have x being multiplied by 1/3, I can multiply by the reciprocal so that it cancels out, leaving my x by itself, and I'm going to multiply the left side by 3 as well, or 3 over 1. And 3 times 9 is 27. So x will equal 27.